Okay, it's new product time.
New.
I'll get a new product theme song at some point. Okay.
I think new is a good product theme song.
You got a couple chips.
We got a couple simple chips. This is the L293D. This is a double full H-bridge chip. So it has 2 H-bridges in it, which means it can control 2 DC motors bidirectionally, or it can control 4 solenoids, or similar like inductive load, or it can control 1 stepper, either unipolar or bipolar. So that's kind of cool. It comes in a dip package, which makes it very easy to use in a breadboard. It has built-in diodes on the outputs of the motor, so you don't have to like add flyback diodes to because there's an inductive spike. Very handy, very easy. There's lots of tutorials on using those, all sorts of chips. They're using the motor shield that we have here, and some people once in a while burn them out because they're like, hey, it says like it can handle 0.6 amps, and I put a 5 amp motor on it, and it broke. Uh-oh. Okay. So you can replace it.
Next up?
Next up is a dual rail-to-rail op-amp, the TS922. We really like this op-amp. We use it in the Wave Shield. It's got a couple things going for it. One, it's dip again, so you can put it in a breadboard, perf board, perf or whatever. Another thing that's really good about it is you get 2 op-amps in one package, really handy. Has a wide voltage range, something like 2.7 volts to like 12 volts or something. So it's a nice big range, good enough for everything. It has high output current, so I think it can supply maybe like 80 or 100 milliamps, which is quite high for an op-amp, which means it can drive fairly large like LEDs or a small speaker, which is really good. And it's also rail-to-rail input and output. So one of the big problems is if you have an op-amp and it's not rail-to-rail input or rail-to-rail output, you can get signals that you're not expecting, because a lot of people have an idealized view of an op-amp. But most op-amps, especially cheap ones, are not input. So if your input is outside of the range, you get nothing out, and you're like, why isn't it working? And if you don't have your feedback loop biased properly, that can also be a problem. So the nice thing about this is that, hey, it's got full input, output, rail-to-rail, so you can use it from 0 to VCC, input and output, and pretty much works just fine.
Okay. Next up, we got some tools.
Yeah, sure.
We spent a lot of time trying to figure out what would be a good one with good value. So we got these now.
Yeah, I can turn this off.
And we can go to the overhead.
Yeah, this is it's kind of hard to see the scale, but this is a handy little tool, and you've got this nice squeezy rubber grip. I like it's kind of rounded, so it's easy to get a grip onto. And it comes with like 36 different bits, and they're magnetically held in, and they're nice and solid. So we've got like Torx and hex, and security bits and triangle bits.
And the neat thing about this is they won't fall through.
They don't fall through.
Yeah, that's nice important to mention. We tried a bunch, and we wanted to get.
It's got an extender too, in case you have to get into.
We all like and use. So this is our
spot. So yeah, this is a good set, and I think we have also just plain screwdrivers.
So wants to know, are the bit standard size ones?
These are all they're all very standard.
Can it take apart Apple devices? So far,
we know it can take apart an MacBook Air.
The MacBook Air, we tested it because it has little pentalobes.
They changed the pentalobes lately, so we might end up getting separate pentalobe drivers specifically for the newest devices, because this set was made before the latest iPhone came out.
My MacBook Pro just has tiny Phillips head, and then my MacBook Air has the pentalobes, and that works with that. So.
Yeah, the MacBook Air definitely works, but then some other devices, I think.
Does it have a tri-wing bit?
It does, actually.
It does.
It does have it has 2 tri-wing bits, and you can go to the product description. I mean, it's very hard to see because it's black, anodized, whatever metal. So but it does have 2 tri-wings. It's triangle, a whole bunch of Phillips, a bunch of Torx, like all the different Torx, all the different hex, and then triangle and security, and a round one for, I guess, pushing stuff out.
Yeah, not bad. $14.95. Good value. We like it.
We like the set. Yeah, I mean, like,
we have a bunch that we did not like, so.
I think that if you want to use a screwdriver or a Torx wrench and you want to get into a very small spot, you should get the screwdriver sets that we have. That it's a full screwdriver. But some people just want to have a bit set, and then this has a lot more attachments. The only problem is that you could lose the bits. Yep.
Next up, this is by popular demand. We got these male to female wires, and we have them in a bunch of different sizes. We'll go to the overhead, but these are super, super, super handy. And
so now we have all of them.
We've got all of them, finally.
So these are female socket, 0.1 inch, to male plug. So this is the extender version. So we have the female type, and then we got the male type, and now we have the female type. So we have all three types, and then we have them in all three sizes. This is the 3-inch long. So this is good for like breadboarding and stuff on a small, breadboard.
Yeah.
We also have the 6-inch type, which is like kind of good for general purpose stuff. And then when you have to make like a really long connection, we also have 12 inches. And the nice thing about these is they come on a 40-pin rainbow cable. So one of the coolest things is, first off, they're like self-storing. It's like you don't have to worry about bundling them. They come in a thing. You can tear them off as necessary. They just like ribbon. It just kind of comes off very easily. And you get 10 colors and 4 of each color. So you have like a wide range of colors, so you can make sure that your wiring is really clean and easy to read. We think that nothing's worse than using like only one color, and then you can never tell which pin is which because there's just a mess of wires.
Yeah.
So if you want to connect 10 wires, you would just rip 10 off, and then you could use all the color coding. So I think that's really handy, and now we definitely have all the different kinds of wires. So if you need any kind of jumper wire, I think we have it.
Yeah. All right. Next up, glands.
Glands.
So here's the product shots.
Yeah, this one is a kind of an interesting one. So this is a waterproof Ethernet connector.
Yeah.
And it's a bit more complicated than the other glands. It's a little more expensive. There's like 6 parts. But basically the way it works is you attach the gland. You attach this this connector, which is it's just a female to female sort of socket, and there's a hex nut in a little rubber gasket here. So this is what you attach to your box. This is your box wall. And so this goes to the inside, and then this would connect to like your router or Ethernet device or whatever using a short Ethernet cable. And then the outside you would have this connected to the cable. So I actually have one of these assembled over here so I can show it. So this is the gland connected to
what's up?
Yeah, this is the gland connected to the cable, and this is just like a standard Ethernet cable, which of course is going to be, oh man, I really shoved it in there. It's hard to get the nib out, but this screws onto here to make that waterproof connection, and there's a gasket inside here, and then this has the actual gland in it, the little rubber round that goes around.
I'll also show these photos too, so you can see how.
Yeah, it's just like it's hard to explain, but basically you have to attach the gland over the cable, and then you attach the female adapter into the box, and then you can. So basically, the adapter is you can disconnect it's waterproof. You can disconnect the Ethernet cable, and you don't have to use this for Ethernet, of course. You can use this for power as well, as long as it's not tons of power. But so we have cable glands and waterproof power connector, so this is sort of like a waterproof data connector.
Yeah.
That's panel mounted. So it can be really handy.
Okay.
Now I really want to try to disconnect this cable. Oh, no.
There you go.
Yeah, so that's how you do it. So very handy if you want to make. These are used for like outdoor wireless routers.
And these are waterproof.
These are waterproof.
Yeah.
They're IP67. They're true. I mean, if you use it properly, you have to make sure like you really clench it down. But there's gaskets in every part of it. So if you use it properly, it is.
Someone wants to know what kind of connectors are there on the Ethernet?
This is RJ45, so you can use it with Ethernet, or Ethernet is a protocol, but it uses RJ45 cable.
No. Okay, next up, we've got these really pretty LEDs.
Yeah.
Yellow, blue, and green.
I have to get the.
These are really nice.
The 7-segment tester out. Yes, these are 7-segment displays, and we got bigger ones. We have smaller ones, but now we have these larger displays. These are 0.56 inch. They still fit into a breadboard very nicely. So let me fit this into backwards. So yeah, you can see this one's the yellow one, and it's got full figure 8 7-segment displays with a dot, and then there's a colon. So it actually, if you look at the data sheet, there's like a fifth digit, and that's the dot.
And here's the photo.
Yeah, there's yellow.
And you can see it on the overhead.
Yeah, so we have yellow, we have green, and we have blue. And I forgot to get red for some reason, so I'm going to get red, and it'll come in like 2 weeks.
Okay.
I thought I ordered red, but I think I ordered blue by accident. But they're really handy. Anyways, these are really great. You can make a clock or a timer or whatever.
Yeah.
They're pretty easy, and they're super, super bright. So even when you multiplex them, they look really good.
All right. Moving right along. We're going to talk about the Menta. So this is our new Arduino compatible.
Yeah.
That fits in Menta. And here's a couple photos. We did a post on Make if you want to read about some of the differences. Make had this first. We developed this with Make, and now we're selling it as well.
Yeah, this is a Make exclusive designed kit. They came to us and they said, "Hey, can you design something really cool?" And I said, "Okay." And then their popular line is the Mintronics line, which is like Mint Tin electronics. And so we're like, well, how about we make an Arduino compatible that fits inside Mint Tin? So basically, like, because I've done so many Mint Tin projects, like we worked on the Y box, and we have some other Mint Tin projects that we have coming out. I took the outline, and then I was like, okay, well, the DC power jack has to go here, and then the LED should go there, and then the FTDI connector should go next to that. And then I took a Boarduino and I pasted it in and whipped it up and then shoved it all as close as I could into the side, and that left me all this space in the middle. Yeah. And so that's where I put the prototyping area, because I love prototyping areas.
Let's start out with the video, and then we'll show it on the other.
Oh yeah, that's a good idea.
Here's the video. This is the video that Becky just did.
Introducing the Adafruit Menta, a portable Arduino-compatible board that fits into a common Mint tin. It has the perfect mix of features to become your go-to hardware for all sorts of Arduino projects. In addition to the standard 5-volt regulator, it has an onboard 3.3-volt regulator for your sensors and other 3-volt devices. All our circuit boards are super high quality, which makes them great for beginners with limited soldering experience. And the Menta comes as a kit of parts and has complete step-by-step instructions to walk you through assembly, even if you've never soldered before. To connect the Menta's DC power jack while it's in the tin, you'll need to drill a hole. Mark where the hole should be and remove the circuit board. I'm using my rotary tool with a conical grinding bit, but you can use a step drill and a drill press, or even a pair of tin snips. With or without the Mint tin, the Menta's got these 4 large mounting holes, free and clear from components on the rest of the board, making it really easy to affix it to a surface very securely. And these rubber bumpers help keep the circuit board from shorting out on the Mint tin. The Menta connects to your computer with an FTDI friend, as shown here, or an FTDI cable. Use these 3 female headers with a small jumper to tell the board if you're powering it via USB or an external power source, like this 9-volt battery holder. Next to the green power LED, the Menta has a red indicator LED. The Menta works with any standard Arduino shield. Solder on the included female headers and use it with your favorite shields. The large prototyping area has both breadboard style and freeform perf board, and you can even stick in a tiny solderless breadboard for more temporary projects. So go build your Menta, show me what you've made in a video response, and don't forget to subscribe.
Okay.
Should I do a tour of it? Or?
Yeah.
Okay. We're here.
Yeah, and I'll shout out some questions if people
sure. Let me try
have them.
Adjust this camera so it's head on. So, right, so this is the Mint Tin shape. You can see this is the shape. It's rounded, and in the corner you have these pretty big mounting holes, and I made sure that there's nothing in the way of the mounting holes. It's super easy to attach this securely to anything you want, which is kind of a pet peeve I have. I hate it when boards don't have good mounting holes. There's a DC power jack. So it's kind of your standard 2.1 inch DC power, so you can connect a wall adapter or battery pack. I have a big 1 amp 5-volt power regulator with a protection diode, so you got your 5 volts here. And then over here I have a 3.3 volt regulator as well, because so many sensors and devices want 3.3 volts these days that it's really great to have a 3.3 volt regulator. Also, if you're doing analog reading, sometimes the 3.3 volt regulator is a little quieter than the 5 volt input. And then we have an FTDI connector here. And so you can plug an FTDI friend or FTDI cable inside. There's a button that you can get to reset it. And we have a green power LED and a red signal LED, and I'll plug it in so you can actually see those lit up.
I'll show out some questions as you're doing this.
Yeah, sure. So there's the
How
power
do you,
LED.
How do you access the 3.3 volt power regulator? Is there a pin?
Yep, there is. It's labeled 3V right here. It's exactly where it is on normal Arduinos. Let's see, we have some filter capacitors, and we have a reprogramming header here. It's optional if you want to install it, but if you want to, reburn the bootloader or something on it, or make some other modifications using an ABR programmer, you can use that. And then, since this is basically just a Boarduino, and a Boarduino is like super skinny, it's like this big, and it would fit into this area, this gave me all the space left over, and so I took the Proto Shield layout, which is, basically a breadboard layout here, and then perf here, so that you can, connect whatever you want, just solder directly on buttons, sensors, displays, LEDs, whatever. And then you can see also on the back, so it's connected all the way through. These are really nice plated through holes. And then there's also a breakout for all the pins on the Arduino, kind of standard over here. You can kind of see them, they're right next to the header. And then finally these header pins, which makes it so you can plug in a shield. So any shield will work. Just plug it in. Very nice. Let's see, what else? Oh, we use really nice circuit boards from Advanced Circuits. These are really high quality. You definitely don't have to worry about these, flaking or coming apart, especially if you want to do a lot of rework and design and stuff. And then we include bumpers, and so the bumpers keep. Well, first off, if you want to use it outside the tin, it keeps it on your table, and so it doesn't move around, which I think is really handy. But another really nice thing about the bumpers is that then you can put them in a tin, and it won't touch the bottom of the tin. And that way you can easily remove it later on if you need to.
Yeah.
There you go. So it fits like into a tin. It's actually kind of press fit. Like I can shake
it won't fall out, so
out.
it's press fit. Yeah.
I mean, it's not like press fit, but it is fairly good fit.
Yeah.
And then
there is room for a mini breadboard too if you really wanted.
Yeah, you can definitely fit a mini breadboard here, and Becky showed that in the video.
Yeah.
So you can use the headers to plug in wires if you'd like.
Yeah.
You want to grab a little breadboard to show?
Yeah, I can.
Yeah.
You want to pull a
Fits
breadboard.
in very nicely. Beep beep.
And do you want to show that it's shield compatible?
Yeah, we just did.
Oh, you already got that?
Yeah.
Okay.
I showed it all.
You got everything.
It's tough to get out because it's exactly the right
Yeah.
size. You have to shake it a little bit.
Shake it a little bit. Yeah, you can be. If you're good at it, you can do it in like one.
Can you should maybe give it to me?
Anyways. No, I was playing with it.
Okay, all yours now. So
okay.
Samantha, so it's basically a cross between a Boarduino and a Proto Shield. It fits in a tin, and I think it's a good portable. If you want to take your project portable and like have it plug in, but you want to have it in a case, it's really good for that. Or you can use it outside the case. Right now we have it with the tin because we think it's handy.
Yeah. There you go.
Thank you.
I want to play.
Okay.
All right. Next up, and this is a monster.
Yeah.
Yeah, this is a monster. Okay. This is a servo driver board. You spent a lot of time on this.
Yeah.
And we're going to power this thing up. These are all, you can do up to 16 on one board. And it's a little intense.
It's going to be really loud.
Yeah, it's going to be loud.
It might get loud.
All right. You're going to put that up there?
Well, I mean, here, you hold on to the water. Plug this in. And then I'll show off the board itself, but I want to demo it.
Okay. Are you going to try to put this up on the thing, or what do you want to do here?
Well, I have to just plug it in. Let's see if this is...
All right.
Hold on, I have to disconnect the output enable pin. Uh-oh. Now my demo's not working.
Somebody's not plugged in.
I know, I gotta figure out what's plugged in.
Well, while Lady Ada figures this out,
yeah,
I will show you some pictures of it. So there it is. We have a little video on our page that you can see this going full speed. But if you reset your Arduino, you'll be ready to go.
There you
wow,
go.
there it
yeah,
is.
sorry.
Jeez Louise.
Okay. I can't see it. So
yeah, here, I'm going to move the
all
camera.
servos.
Yeah, I'll move the camera to it. So, oh, you want to do it that way?
All servos. All moving. Yeah, this is 16 hobby servos, all being controlled. They're like little crickets or something.
Yeah.
This is proof.
So, yeah, everybody, when we showed this, is like, oh, can they all go at the same time? Yeah, of course it can. And
Yeah,
this can also be used for LEDs.
It can be used for LEDs. I kind of designed this for servos because for LEDs.
We should call it like the Medusa board or something like that.
You want to show it on the overhead?
Yeah, I'll show it on the overhead.
Okay.
Yeah.
But they're all
Back
kind
it
of
up
crazy.
a little bit, yeah.
They're going crazy. Oh my god. So you can see they're all connected. Alright, is that enough? Can I stop? Can I stop?
No, we're just...
It's going to be the rest of the show.
The servo driver board's going to host the show. Okay, let's answer some questions.
Okay, let me do a walkthrough of it, and then we'll answer some questions.
Okay.
I think when I talk about it with the overhead, that will answer a lot of questions, and I can do it in order.
Okay.
Okay, great.
You show it. Everyone, hold your questions until she's done.
Okay, great.
All right.
So I'm going to show this, and then this is the board that's unsoldered.
Yeah.
Sorry, this is the board that's unsoldered. In the middle is the actual driver chip. It's the PCA 9685. And then over here is where you would connect the motor voltage power. So this has a split power supply. There's a connection here, terminal block connection, which is what you use if you want to power the servo separately, which is probably what you want to do, because a lot of times your motor power will be separate than your logic power, because otherwise the motor power gets super noisy. So in this case, you can see I connected it to a 2.1 millimeter DC jack to the terminal block. And then we have, it's very small, so it's kind of hard to see, but there's a protection FET here. It can handle 4.5 amps or so. And this is to make sure that you don't connect this motor voltage backwards. And there's a power LED that'll light up to tell you then you've got power. Next up, there's a spot for capacitor. We don't include a capacitor because depending on what you're doing, you may or may not need one. And how big it is also depends on what you're doing. If you're sharing the motor power with the logic power, you might need it to help smooth out the ripples. We have connections on the side for ground, output enable, so you can disable all the outputs at once if you want to. Clock, I2C clock, I2C data, VCC, which is the logic power, and V+, which is the motor power. And then we have four groups of four 3-pin headers, so it's 16 total, and they're numbered 0 through 15, and that's what they're called in the library as well. And the reason that they're in groups is because servo connections are slightly wider than 0.1 inch. They're like 1.105. So if you end up stacking more than 4 together, they don't fit very nicely. And so you can put 4 together and they'll kind of squeeze, but any more than that and they won't fit. So that's why we have gaps in between. We have little resistors, 220 ohm resistors, because this isn't constant current mode. This is a constant voltage output. So if you want to connect LEDs directly, you've got 220 ohm resistors. So that should be good enough for most LEDs if you want to just drive them directly. And then on the back, there's some information about the board. You can use logic between 3 and 5 volts, and it's 5 volt compliant, so you can drive 5 volt outputs with 3 volt logic on it. That's a nice little chip. The frequency can be adjusted. For all of them, you can adjust the frequency from about 40 hertz to, actually it says 1,000, but it's actually 1.6 kilohertz or so. And so the nice thing is that you can have this be 1.6 kilohertz for LED output because you want to have a higher frequency, and then dial it down to 60 hertz for servo output. And the frequency adjusts all of them, so they all are at the same frequency. It's not like one per. And then I'll show basically the connection here, so I can show what it looks like with all the servos connected.
I like what you did. They actually made it so they fit.
Yeah, so you can see that they come out just a little bit. They're a little bit too wide, but they do fit, and they're I see it all the time. It's okay to have them just a little bit wider than normal. And then for people who want to go a little slimmer, we also have a little accessory pack. We could decide.
Yeah, we have these right angle.
Whether right angle or straight. We decided to go with the less expensive straight ones, and then we added the right angle ones.
Oops.
So if you want, you can add a right angle header, and so instead of pointing straight up, these would be pointing up to the side. And so you can add. They're a little more expensive because they're much more complicated. They're right angle style. Yeah, so this does work with LEDs, but I kind of decided that I think most people want. It's best for servos. Oh, I forgot the last thing to show off is the address selection lines. So over here, there's solder jumpers. One of the cool things about this chip is you can set the I2C address up to 64 different options by shorting these 6 jumpers in any combination you want. There's 2 addresses you can't use because there's like something special about them. It says so in the data sheet, but you can use 62 addresses. So you can connect 62 of these, and you can connect them like side by side and just jumper these wires if you want, because they're identical on both sides, or you can connect them however you want. But share the same I2C pins, the 2 pins, and then have separate motor supplies if you want, power supplies, and you can address up to like 990 different PWM outputs. So this would be great for any kind of massive PWM project.
Yeah.
And we think this is really good we see people want to do like walker robots or like hand robots or any other kind of articulated robot where you have more than 3 or 4 servos, and then you're like, shoot, I just ran out of PWM outputs. And this is really nice because it can do it all. Another nice thing is it's free running, has a built-in crystal or oscillator. So you set the frequency and the output, and then you don't have to talk to it again. This is unlike the TI chips, the 9420 or something. I don't remember the name of it, but the TCL 9420 or TLC 9240 or whatever. Those chips, you have to constantly send them signal. If you don't, it stops. You have to clock them.
Yeah, everything stops.
These have an internal clock, so that's handy.
Yeah, I remember when you showed me the differences. I'm like, wow, this is like what I think of the classic Adafruit design, where you really put a lot of thought into this. And this will be, I think, the weird product that we have that, like, we'll see robot centipedes, we'll see, like, giant amounts of servos, and you have so many pins for you so you can do other stuff.
Yeah, so you can still have displays or sensors or whatever, and then you have these, and they're running, and you can drive them very quickly. So I like it. I was actually not looking for a servo driver chip. I was actually looking for an LED, I2C LED driver chip for a future project. But I bumped into this chip at the NXP website, and I was like, wow, this is so awesome. This chip is so cool. It's a free running PWM output driver. I gotta it wasn't too expensive. I was like, I gotta make a breakup board for this. And so Kevin designed this great breakup board.
Yeah.